Hello everyone, I'm Dr. Raman. In this section, we are going to discuss with homogeneous linear partial differential equation of second and higher order with the constant coefficient. The previous session, the videos are already given. You just check once again before that complementary function and what is a homogeneous linear partial differential equation of second order, higher order, everything we have given. Now in this session, particular integral, how to calculate particular integral and what is the type of particular integral, we are going to discuss with that. First of all, the function of d comma d dash z equal to r of x comma y. R is nothing but another one function of x comma y. So this is a left hand side problem. When the question is given, we consider this left hand side and this is a right hand side. Okay, for here, how to calculate particular integral? Particular integral pi equal to 1 divided by left hand side into right hand side. So what is the left hand side? The function of d comma d dash into another function of x comma y. The r of x comma y based on, we have some type, because this is a based on the value based on the type. Now type 1, when the right hand side value, type 1, when the right hand side value, that is r of x comma y, e power ax plus y, this is a one of the type, e power ax plus by. Now how to calculate this? The particular integral is nothing but 1 by the function of d comma d dash into r of x comma y. Now the r of x comma y is nothing but e power ax plus by. Now that just replace d equal to a, d dash equal to b. When I am substituting here the function of a and b, e power ax plus by. Now this is a solution. If f of a comma b, when f of a comma b not equal to 0, then this is our particular integral. When the f of a equal to 0, then we should use some process. What is the process? For example, the particular integral 1 divided by 0 e power ax plus by, then you just move on to the previous step. What is the previous step? The previous step is nothing but equation. We consider this equation maybe 1. Okay, now the going to shift the previous equation number 1. In this equation, the numerator and the denominator. Okay, therefore when f of a comma 0, then the multiply numerator, in this case numerator multiply by, in numerator multiply by x, and then denominator differentiate with respect to d, differentiate with respect to d, then replace d equal to, and then after that d equal to a, d dash equal to b. If again you are getting 0, then same procedure to continue. If we have value or f of a is not 0, then this is our particular integral. And then type 2. Type 2. The type 2 right hand side, sin ax plus by or cos ax plus by. This is our type 2. In this case, how to calculate particular integral? 1 divided by the function of d comma d dash into sin ax plus by or cos ax plus by, then substitute put d square equal to minus a square, d dash equal to minus ab, d dash square equal to minus b square. So this is a type 2. Then is denominator 0, same procedure. Then type 3. Type 3, the right hand side value, that is r of x comma y, x power m y power n, x power m y power n. Now the particular integral 1 divided by the function of d comma d dash into r of x comma y. This is nothing but f of d comma d dash x power m y power n. For this condition, when m greater than n, then take d common out. When m less than n, take 1 by d dash common out. I will show it when solving the problem why the d we are going to take out. Now the form 1 minus x whole inverse, the binomial form, whole inverse 1 plus x square plus up to etc. Then 1 plus x whole inverse is nothing but 1 minus x square and so on. So these are the 3 types. And the fourth type, type 4. Type 4, when the right hand side e power ax plus by, when it's a plus, we just calculate particular, suppose here is a plus, and then sin cx plus dy, then this is a consider particular integral 1, particular integral 2, then should individual to calculate type 1, type 2, then we just add type 1 value, type 2 value, it's our particular integral. But here when product is given, when is a product, if when is a product, then is another type sin cx plus dy, and then or e power ax plus by cos cx plus dy, or e power ax plus by x power m y power n. So in this case, how to calculate particular integral? Pi equal to 1 divided by the function of d comma d dash, and then e power ax plus by and sin cx plus dy, or e power ax plus by cos cx plus dy, or e power ax plus by x power m y power n, and then replace d equal to d plus a, d dash equal to d dash plus b. This a b is not a sign, because why I change sin c and d, don't get confusion. Here a b value is exponential, that is a power. This value only to substitute. This is a a and this is a b. This value only I am going to substitute fourth type. When I substitute d equal to d plus a, d dash equal to d dash plus b, once you substituted this condition, then u power ax plus by, it will be put in the front side. So the process will be over. Then it should be a value of 1, a function of d plus a, d dash plus b, then sin cx plus dy or cos cx plus dy or x power m y power n. Now the fourth type, when I substituted in this condition, it will be reduced to type 2 or type 3. If the problem based on the type 2, type 3, we just solve same procedure. This is our type 4. And then type 5. Type 5. Type 5 is right hand side, when x power m y power n into sin ax plus by or x power m y power n cos ax plus by, and then this is a right hand side value. And when I substituted this part type, and before that, if e power I ax plus by is nothing but cos ax plus by plus I into sin ax plus by. For this term, when real part of e power I ax plus by is nothing but cos ax plus by, because this is a real part and this is a imaginary part. An imaginary part of e power I ax plus by equal to sin ax plus by. Therefore, now the problem how to calculate particular integral when is given 1 by the function of d comma d dash x power m y power n sin ax plus by or x power m y power n cos ax plus by, and then to replace this sin function, which function? This sin function or this cos function, imaginary part, this is a real part. Now should write this imaginary part of, this should be right real part of e power I ax plus by, and this term imaginary part of e power I ax plus by. Therefore, in this term, real part of 1 divided by the function of d comma d dash x power m y power n e power I ax plus by, or when I am taking imaginary part, or imaginary part of 1 divided by the function of d comma d dash x power m y power n e power I ax plus by. This term is type 4. Now this is our type 4. When should solve type 4? As usual, same procedure. What is the type 4? Put d equal to d plus a, d dash equal to d dash plus b, then the term will be reduced into third type. So it will be reduced to third type. Therefore, imaginary part of e power I ax plus by 1 divided by the function of d plus a, d dash plus b, then x power m y power n. Now this is our type 3. To solve type 3, this is a type 1, type 2, type 3, type 4, and some general type. The general type is nothing but when we use the rule, the type 5, this is a type 5. Now we are taking some type 6 is a general rule. Type 6 general type. This general type or the function r of x comma y may not always be about type. Maybe we consider this function. Now this function we just consider the right hand side, the function y into sin x may be factorized into linear factor. So maybe this term y into sin x or y into cos x. We use this form, and 1 divided by d minus m d dash, and then r of x comma y should be the value of, because of the particular integral, 1 divided by d minus m1 d dash and d minus m2 d dash and so on, d minus mn d dash into r of x comma y. For this term, when is 1 d minus m d dash the function of x comma y, this is nothing but integral over r of x comma c minus mx into dx, where here I am going to take y equal to c minus mx, y equal to c minus mx, or d plus m d dash, the function of x comma y, integral over r of x comma c plus mx into dx, where y equal to c plus mx. We just apply with this general type. Now we are going to solve some problem for the next session. Thank you.